Okay, number 5. Two currents from different sources flow in opposite directions through a resistors R1. Okay, two currents flow in opposite direction in R1. We have I1 and I2 that flow with different direction. I1 is measured as 79 milliamps on a 100 milliamp analog instrument with an accuracy of plus minus 3% of full scale. Meaning that I1 is measured as 79 milli. It is measured by analog instrument with 100 milliamps at full scale with an accuracy of plus minus 3%. Plus minus 3% is the accuracy of this analog instrument. I2 is determined as 31 milliamps. Is measured on a digital instrument with plus minus 100 microamp accuracy. So I2 is measured as 31 milliamps. The error of the measurement is plus minus 100 microamps. So we do not need to find the error of I2 because it is given. Calculate the maximum and minimum levels of the current in R1. Why we need to find why the question asks us to find the maximum and minimum levels? Because due to the error, it is plus minus, so we will have the reading of I1 and I2 in certain range. So we can find the maximum and minimum level. I1 is 79, it is given. So the accuracy of the 100 milliamp is plus minus 3%. So we can calculate the limiting error in absolute form. So 3% multiplied with 100 milli, we get plus minus 3 milliamp. So I1 is from 76 milli to 82 milli. How to calculate this? 79 minus 3 milli, we get 76 milli. 79 milli plus 3 milli, we get 82 milliamps. So any reading that is in the range of 76 milli to 82 milli, it is acceptable. I2 is 31 milliamps with the accuracy of plus minus 100 microamps. Okay, so 31 milli plus 100 milliamps, we get 31.1 milli. 31 milli minus 100 milli, we get 30 milliamps. Meaning that if you measure I2 and you get the answer from 30.9 milli to 31.9 milli, so it can be accepted. Let's say you get 30 milliamps, so consider as correct. So IR, since the I1 and I2 flow in different directions, so IR is equal to I1 minus I2. Okay. So I1 is equal to IR is equal to I1 minus I2. So how to find the minimum IR? So 76 milli minus 31.1 milli, we get 44.9 milli. To get the maximum value of IR, 82 milli minus 30.9 milli, so we get 51.1 milli. So if you get IR in the range 44.9 milli until 41.1 milliamps, so it can be accepted. Let's say you get 48 milliamps, so your answer is correct. Okay, this is number 6. A resistance box has the following components and tolerance. Okay, imagine that you have a box. In that box, you have 10 resistors of 100k, 10 resistors of 10k, 10 resistors of 1k, 10 resistors of 100 ohm, and 10 resistors of 10 ohm. Each type of resistor has its own accuracy, 0.05%, 0.1%, 0.5%, and so on. Okay, the question is to find both in ohms and percentage of the limit of uncertainty in setting of 453.72 kilo ohms. Okay, so now we want to get this value. Okay, 453.72 kilo ohm, meaning that in your breadboard you have to you have to pick, okay, you have to pick several resistor from this fixed value of resistor to form this value for 53.72 kilo ohm, meaning that you should get you should get 5 resistors from these resistors, okay, from the box. Okay, please be noted that resistor comes with fixed value. Okay, let's say 100k, 10k, 1k. So if we want to form this value of resistance, we should pick certain resistors and connect it in series to get the value. Okay, now the question is to find in ohms and percentage of uh, limiting error to form 453.72 kilo ohms. Okay, now let's find the absolute error, okay, the limiting error in absolute form for each resistor. This is 100k, 10k, 1k, 100 ohm and 10 ohm. Refer to here. Okay. Okay, so for 100 kilo ohm, 0.05% times 100k, we get 50 ohm. Same goes for other resistors. Okay, other type of resistors. These are the value of limiting error in absolute form: 50 ohm, 5 ohm, 0.5 ohm, 0.1 ohm, 0.05 ohm. Okay, so now uh, let's find the okay, you can skip this step, okay, because we know that to form 453.72 kilo ohm, you should have 4 pieces of 100k, okay, plus 5 pieces of 10k resistors, plus 3 pieces of 1k resistors, plus 7 pieces of 100 ohm resistor, and plus 2 pieces of 10 ohm resistor to get this resistance for 53.70 kilo ohm. Okay, after that, we want to find the total limiting error in absolute form. Okay, so plus minus in the bracket of 4 times 50, okay, plus 5 times 5 plus 3 multiply with 0.5 plus 7 multiply with 0.1 plus 2 multiply with 0.05. Okay, the total is 227.3, meaning that to form a resistance of 453.72 kilo ohm, the total limiting error that we should allow is plus minus 227.3 ohms. Okay, now let's find the percentage of error for the total resistance. Okay, 227.3 divided with total resistance plus multiply with 100 because we want to get the percentage. So this is 0.05 0.05% is the percentage of error of the total resistance for 53.72 kilo. Okay, number 8. Number 8. The unknown resistance is determined by Wheatstone bridge and is given by Rs is equal to R2 R3 divided with R1. Okay, Wheatstone bridge will be explained in detail in chapter 5, I think. Okay, so here just ignore about Wheatstone bridge. given Rx is equal to R2, R3 divided with R1, where R1 is this, R2 is 900 plus this, and R3 is equal to 825 plus minus this error. Determine the magnitude of the resistance and the limiting error in percent and ohms for the unknown resistance Rs. Okay, so magnitude of resistance, we just use this formula. Okay, substitute R2 is equal to 900 multiply with R3 divided with R1, we get this. So Rs is 8.25 kilo ohms. Limiting error in percent and ohm. Okay, so limiting error in percent. So the percentage of limiting error for Rs is equal to, okay, since the limiting error in percentage for R1, R2 and R3 are given, so we just take the values, we just add all the error because the relationship is division and multiplication, so we can just add the error. 0.5 plus 0.8 plus 0.6, we get plus minus 1.9%. How about the limiting error in absolute form, okay, or in ohms? So we just multiply the percentage of error, okay, 1.9%, okay, multiply with the total resistance, and we get 156.75 ohms. Okay, so this total resistance 8.25 kilo ohm has the limiting error of plus minus, okay, you should put plus minus here, plus minus 156.75 ohm. Okay,